howdy, 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 students. This is Mr. Dawkin, and you are going to learn how to write electron configurations using a shortcut today. In the previous video, we learned how to write electron configurations in their full form, but what we're going to find is there is a shortcut. So if we look at this picture up top, what you'll see are the groupings of the periodic table. There's 1s, 2s, 3s, so on and so forth. You got 2p, 3p, 3ds, and you can see how the periodic table's kind of busted up into these sections. So if we're writing titanium, we can write the electron configuration using the old way. So titanium is the second element here in the D block, and it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Remember, it drops down to 3d, and then we're going to count 2 for titanium. Now, that's the long method. We have a shorthand notation, otherwise known as the noble gas notation, and it goes something like this. What you're going to do, wherever the element sits, you're going to go over and find the noble gas that's in that row. And for titanium, that noble gas is krypton. You're going to go up and find that noble gas, which is argon. So we don't want krypton, we want the one above it. And what we can say, we can put argon in brackets like this, and we can say, you know what, we know everything up to argon, and then we can read like a book and go from there. So from argon, all we have to say is 4s2, 3d2. It shortens it, and it's called the noble gas notation. So let's go ahead and use the shorthand notation to write the electron configurations for these elements. So if I am looking at aluminum on the periodic table, argon is the noble gas in that row, but I want to go above it, so I'm going to bracket neon. And I'm going to read from there, and it would be 3s2, 3p1. Okay. What I would do if I were you, I'd pause the video and see if you can go ahead and write these out, and then I will continue, and you can check yourself as you go along. Potassium would be brackets argon, 4s1. Iron would be bracket argon, 4s2, 3d, and iron is 1, 2, 3, 4, 5. It's the sixth one in that row. Cobalt, also in the same row. It's 1 next to iron, 4s2, 3d7. It's the one next to it. And bromine, we bracket argon, and we would say 4s2, 3d, and there's 10 of those elements. And then we come back to 4p and count all the way to bromine, which is 5. And that is the shortcut method to electron configurations.